Hi, my name is Zachary Angela, and I want to go over sort of the generalities of learning neural networks. Um, I'm no expert at it, I don't have much of a background in it, but from what I've been trying to learn from and trying to kind of do it, um, I was just going to try to do one video of just the generality of it and not get too much into the weeds of it just because it can get kind of boring and hard to watch. So so basically, from my understanding of not really having a background in it, but kind of diving into it, because I was working on trying to do it. Um, I built something that uses tagging, and it's still I don't have a big data set. I still gotta make that. It's only like 40 of them. That's why it kind of doesn't get things right. But you have to understand that um, it has to start from scratch, sort of. And so if your data set just isn't that great or that expensive, then when you do pass it in sentences or data, it only has a certain pool to pull from. I am using my tagging program as like a comparison thing, so it doesn't use the 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 program itself to tag it. It uses it to predict, I guess you could say, or help predict the tagging in some form of accuracy. So it'll say right off the bat it doesn't have certain words inside its vocabulary, and that may be because of my tagging, probably. And then it does like an accuracy count by trying to tag the things, finding errors, and then comparing it to my program. It sort of begins to assess, I guess you could say, what tags it actually spat out. And as you can see within their tagging, and it does change each time you do it. It's sort of trying to understand what's going on. So instead of just running my tagging program and just filtering through stuff, it's trying to learn on its own, but kind of doing a comparison thing in order to get the tags so that it can tag it. Um, but without getting into the weeds of kind of what's going on, I just want to do a generality of what it is. I will admit the math part I'm not exactly too experienced in, and I don't exactly have any background in it, and I don't entirely understand the math 100%. And this by no means is some kind of neural network that is expansive. I mean, it's a simple one, um, doing bare bones stuff in order. And the reason why I made it was because I wanted some to understand more what's going on, um, so that when I do have these functions, I do break them down. I will refactor them. I will comment them. It's sort of to break down the concept of actually what's happening, so that when I do build on it, when I do try to improve it, um, I I'll be able to weld it, I guess you could say, in a sense, or improve it, or add it to other projects, or whatever it is that you want to do. And that's kind of why I wanted to make a really bare basic video on kind of what's going on, and maybe venture into my mindset or mental model, as poor as it may be. Um, so, what at a top level, or not top level, but I guess you could say a low level, but it's a basic level of what you're doing is, um, and I'll try to compare my code while I'm explaining it, sort of. So you have your model, which you could think about it as neurons, right? Input weights, certain functions in order to change all the data to be like really positive or to be in the certain part of the graph or whatever it is that you're trying to focus in on. Because if you just have math for the sake of math, it's just going to get way too complicated. So you have these certain basic functions, and in my code, the NNU is basically neural network utility. But you have, max index. You have, actually, I think I put the other one in here into the actual simple network. Oh yeah, and it loads it and saves a GOB file. Why did I choose a GOB file? Uh, 'Cause you reiterate through this thing so many times. You could use a database, but you have to change how it works and what it does. Also, I'm not yet, at least right now, tagging or having it predict tags for phrases and dependency relations. It's it's the data's there. Well, not entirely, but it's tagged, and I just added ner tagging prediction. Obviously, it's not working out the greatest, but eventually I worked the other ones in. I just want to put them together for right now, and then working on improving all of them with these bare basic functions, and just to try and keep the structure simple, even if it's not truly neural network stuff or getting deep with the analysis or predictions. I'm not saying it's all that accurate. I'm just trying to understand what's going on and, in a certain sense, uh, make notes and learn as I'm going while trying to keep it simple, while trying to weld what's going on. So it's going to be a slow process. It's not a truly correct process, but it's a process of how I'm trying to keep the mental model little and then kind of break out from there, sort of, so to speak, from a pure code perspective, not necessarily a, you know, scientific neural network perspective. So some of it might be wrong, and that's fine. It just, I'm trying to break down what's going on. Anywho, so when you make the model, you're basically trying to do prediction. Well, you have this data, the inputs, and a lot of that is is and when you do the neural network stuff, you do have to put things into numbers. That's sort of what's going on here. So you have the tokens, right? The sentences or whatever, and then you have the tags, which are also strings, but you have to translate that into numbers. And then you have these functions that you just sort of memorize in order to use that data and then put more of the tags or their order or whatever it is into numbers. Hopefully I'm not confusing it too much, but basically you have your sends, your tags, you translating them into numbers. That's it for what this is. And you use certain functions in order to do that well. You just gotta memorize the name of the functions, and that's pretty much it. These graphs with the outer layer, hidden layer, input layer, these are more where the math starts to get interesting, I guess you could say. Because, yeah, you start dealing with learning curves, and you're trying to use that data and trying to get errors out of that data, and the error is a certain number, and you're trying to use the weights, the biases, and corrections of those errors in order to change the numbers. Well, what does that mean, in a sense? I think the best way. Well, this is a good diagram, I think, where You have a neural network that's dumb, doesn't know anything. You have this data that's something else. You're translating into numbers. You're using these functions in order to make sense of the numbers. And through making sense of the numbers, you're kind of, in a sense, beginning it to learn, at least through correction. Um, so, kind of says our goal is in using a neural network is arrive at a point of least error as fast as possible through repeated loops. That I mean that makes sense. You know, at a very basic level, you take in inputs, times them against weights. These are so in the tagging world, it'd be tokens and their tags, and they're worth a certain value. You run it through a function in order to turn in the numbers and maybe turning them all positive, whatever it is that you're trying to do to manipulate the data in order to make sense of the numbers. And in a small sense, this is kind of what you're doing. You're taking some data that's a guess, you're turning into numbers, and you're like timesing them or dividing them or whatever, and then you're taking an error and you're comparing those numbers, which are guesses, which is your data, and your truth or your Golang files or whatever you want to call it as another number to compare it to. So what you're doing is you're taking text and the tags. You're translating them into numbers, but you also have the correct tags or more correct tags or whatever you want to call it. And when you translate those into numbers, you're then taking the two numbers and you're making an error correction thing, and you're running it through functions in order to say, well, this is how big your error is. How can we lower this? So that's basically what this is. And it's not so much, I mean, the math is important, but it's not so much important when you actually have it down. It's important to realize that when you use these functions, because they're pretty well defined, you just gotta Google them, like forward, pass, back propagation, all that. Even LLMs have a pretty good idea what those do and why. You could get into the weeds when you get too far into it, and I tried to stay away from that. Hence why it's not totally correct. There's you go really far into each part of it, even the correcting part. What was it, RELU, where there's a whole bunch of functions and trying to correct the error data that get, all these algorithms and stuff. I'm trying to stay away from that as much as that would help make it more correct. I'm just trying to break it down. As you can tell, like it starts to get weedy. And explain this stuff, I mean, I don't totally have a background in it. I sort of understand what's going on, especially when you think about it in the graph concept. But the important thing to understand is that you're trying to correct that error number while you're running it through all that data. And what does that mean kind of code-wise? Well, you create a vocabulary through the senses and the tagging or whatever it is. The actual training part, and why you have to do a huge amount of loops, is because it's in a matrice. You can basically think about it as like this thing, basically. And so it's not enough to turn the tags into numbers. You have to turn them into an organized row and columns of numbers. And when you do that, you have to loop through things a certain way and turn them into numbers, and then run your functions over those numbers, like forward pass and back propagation and calculation error and all that. And you just have to accept the idea that you have to turn the numbers. You just have to accept the idea that it has to be matrices. You just have to accept the idea that there's certain functions you use that have certain algorithms that do those things. There's no there for a one-liner. There just isn't. So, I mean, that weights times biases thing, sorta, in a sense, is a one-liner understanding of it. But as long as you keep these concepts and these words inside your head while you're working on it, um, it, it takes some it is complicated. I'm not saying I totally understand it, but it makes your view looking down on what's going on a hell of a lot easier to deal with. You're not thinking, well, is it hitting this specific number and times in against this specific bias when I run it through this matrix? You're not doing machine logic in your head. You're keeping concepts and you're attempting to, at a high level, figure out what's going on just by output. Hence why it's not 100% accurate. You do have to have a big data set, and there's always ways to improve things. But when you use Go, you want to keep things readable so you could reuse parts of it. And I haven't entirely done all that. You can kind of see it begin to learn. If I did this. But this just shows it running through the data set. But I guess it does give you an idea of kind of what's going on. So it runs 100 epochs through this data because it doesn't know anything. And then it tries to calculate the error for what's going on in order to produce these tags. And comparing it, the tags that are from my tagger program, is sort of there's a word for it, but the suggest, right? And that's basically kind of what's going on from a really simple level. As I learn and as I break it down more and actually do phrase tagging, dependency tagging, and have it broken down, I'll get a little more granular into kind of what's going on and why. Again, it's not totally correct. Again, I don't entirely have a background in it. And I'm trying to manipulate things to keep them simple. So it's not 100% correct. But I'm using bare basic concepts, trying to break it down, and I'm trying to make it readable and understandable. Even if right now it's not entirely all that much. As you can tell, it's mostly all in one file. That's huge. And I did kind of switch around, break it down, and all that, but I got to refactor. And then I'll have some somewhat simpler. Obviously, the math part, there's just not a whole lot you can do about it. I mean, calculator, I guess you can break down certain parts of it. I'm not even too sure what they'd be named, but they are, in a sense, broken down into functions, right? But you want to keep those function names what they are so that they do what they're supposed to do, so that, to try and simplify that more, I think is you're breaking the name scheme. Well, maybe not. I guess if you create your own names, it doesn't entirely matter, but for understanding's sake. Yeah. Anyways, if you need anything, I guess let me know. Thank you, and bye-bye.